Today we show the power for SolidCAM, HSR and HSM. We show also the HSR, HSM faster and of course easy to use. Here we have big parts. The size is 720 millimeter. We can see also complex geometry and also a lot of surfaces. In SolidCAM 2014 we do several improvement in HSR and HSM, and the main change is to start to work faster with big parts. Means we can define coordinate system faster, target, stock. Also we add a new option to calculate the updated stock. Today we have only one option. The name is now regular, and we add a new option. And I want to show also the new HM operation. It's very nice, very interesting operation. We have several options to cut parts like cavity, core and HM spiral. And also I want to show in the last example the easy to use, the power for HSM. That means the complete fast solution for 3D model. I want to start with this part, and if I pick here you can see the size of the part more 700 millimeter, and I want to start to add, that means to define the camper to see how easy and fast we can work today. We start to define the cam part now, and before, if we compare the SolidCAM 2014 with SolidCAM 2013 SP5 and all the version, you can see how fast we can work today. This is my part, and you can see here really very big part, complex part. And what we have here, first I want to define coordinate system. In the coordinate system we do also very nice change today. The default to work without the high precision, because I see my part is that means the size, the parts look like box. I don't need the high precision. But if you want to work with high precision, always in the SolidCAM settings today you can check on, and always you can use high precision. First, I want to pick the surfaces here to define coordinate system. You can see immediately I have the coordinate system. I do the flip and my coordinate system is ready. This is really the big change. Before, if I want to work in the same part, it can take more 2 minutes, but now you can see few seconds and we have coordinate system. We continue with the coordinate system. We finish the coordinate system. Also here we had, you can add from here, not only with right click, you can do edit, everything from the user. Now I want to add stock. First, my default to select the stock automatically, but I want to show after we select automatically, I can in one click select the stock. That means I want to do unselect, pick the model, and I have the stock immediately. Also, to define stock in the old version take more time, but now in one click we have the stock. I want to continue to show also how we can select target. The same process I have in the SolidCAM setting to select the all. I want to delete, to do unselect, and to select the target again. I want to change to top and select also the surfaces. I want to show all the process, and after I select the surfaces you can see immediately we have the target. Now we finish. What I want to say, I think today we faster more 400–500% if we compare with the old version. Now we're ready to start to work. That means to define coordinate system stock target. You can see how faster we can do this today. Now, I want to talk about the big change we do in the updated stock. Today, inside SolidCAM setting, we add a new option, updated stock. Till SolidCAM 2013 SP6 HF1 and SolidCAM 2014, we have only one option to calculate the updated stock. This is the regular, and now we add a new option, special for HSR HSM. What I want to explain when we need the regular option and when we need also the special for HSR HSM. If we work with multi-side, if we work with 2.5 axis, 5 axis, HSR HSM, of course, to calculate the updated stock, we continue to work with regular option. But if we work with big parts, only with HSR HSM, of course, we need to work with special for HSR HSM, because we testing this option in several parts and we compare the time. Special for HSR HSM in some part is faster 100%. In big parts maybe can also faster with 60-50%. And we talk about hours, we talk about a lot of minutes, not only 1, 2, 3 minutes, and this is faster 60%. We can talk about, okay, 2 hours, and now it's faster 60%. That means a lot of time. And now I want to use the option special for HSR HSM, and I want to show how we define, and I want to use the HM rough, and I want to add 2 rest rough operation and 1 finish operation. If we look for this part, and now I want to start with HSR HSM. We have now HM roughing. I think this operation is really, first is have a lot of option. We missed this option before, and we have several options to cut any part. That means you can cut cavity part, core part, HM spiral. In example 2, I go to show really the power and the easy to use for this operation. Now I want to add HM rough, and later we can explain all the parameters with this operation. Tool. I want to add a new tool. This is the tool, and I want to work external because I want to cut all the part. And also, what we want to show in this part and in all the part, we demonstrate first the power for the HSM, the easy to use, and how we can work fast. That means to start the part in few minutes, we can finish the part, and we can really work fast. This is the boundary. Now I want to work with wall offset, and I want now to talk about tolerance. A lot of customers sometimes do mistake, because if we look for this part, this is really big part. My wall and the floor offset is 1 millimeter. Never work with tolerance 0.02. You can change to 0.1 because the wall and floor is 1 millimeter. Of course, you can calculate faster, and nobody need this tolerance. We do this tolerance because sometimes we afraid you can do finish and forget to look the tolerance, you can damage the part. But with 0.02, never damage the part. But if you work with big parts, you can check the tolerance to 0.1, 0.2, everything is okay. Now, I want to talk about step down, 5 millimeter, and really the power for HSR that we have in all the fields formula. That means for me, I have geometry, tool, boundary, wall, floor, tolerance, step down, and that's all. We do the calculate now. And this is really the easy to use in HSR, HSM. And now, when we work with tolerance 0.01, you can see big part, but we can calculate fast. Now you can see we calculate the link time, more 50%. Now we finish to calculate the link and we generate toolpath preview. This is very important. Before, if I want to see now all the toolpaths, today you don't need to run simulation to show the toolpath. It takes time. Today, with one click, you can see all the toolpaths. This is also a very big change we do in HS, but in all SolidCAM operation, but you can see really the effect in HSR, HSM when you have really very long toolpaths. Now, I want to continue with ResTraf. I want to change now to ResTraf, the same target tool. We use different tool now. We have the tool, the same boundary, and of course wall, floor, and tolerance, the same tolerance. My step down is 2 mm. Minimum offset, the wall is okay. That means we have ResTraf, and we only do the calculate. And now we use the new option to calculate the updated stock. If we compare this part with the regular option, of course, I check this more 50%. Now you can see we do faceting now, and after this we start to calculate the passes, the link. Now we start to calculate the passes. After this, the link. I want to check in the SolidCAM setting which option we have in the advanced contour roughing, because what I see now, if you see the dialog when we show the calculation, this is for regular. And now you can see we calculate the passes. After this, I want to run the same operation with the new option. I want to show also the difference between the calculation time. Don't forget, we talk about big parts, a lot of surfaces, complex geometry, but really work fast today. This is the passes calculation time. Now we start to calculate the link. And also, when we switch now to special for HSR, HSM, I want to show also the toolpath. I'm sure when we work with special HSR, HSM, it's not only faster, also the result is better. That means he find more area to cut. And if I show now the toolpath, you can see the toolpath with the regular updated stock. Now, if I go to the settings, to the updated stock, We work with regular. I want to change to special for HSR, HSM. Do OK. Now, I want to clean the CAM part. I want to open again the operation and do calculate. You can see, of course, we calculate the STL now, and you see with the new option all the calculation inside this dialog. We can see now really how the updated work faster. You can see now we calculate the passes. Before, to calculate the updated stick, you see it's take time, but now with the new option you can see now we calculate more 30% from the passes. And this is one part. We check the new option with big parts more 10 meters, and you can see if the calculation take 1 hour, with the new option take 20-25 minutes. It's really a lot of time, and with the new option, if you're using only HSR, HSM, really you can win a lot of time with the new option in HSR, HSM. And you see this in here. You remember before how many time take the calculate, and now with the new option you can see really work faster. And also the result in the regular is good, but I'm sure in the new option is better. Now I want to show also the toolpaths. You can see we finish, and of course we see the different in the time. Also, if I look in the toolpaths, the result here is better, and this is the reason we add this option. And always, if you work with HSR, HSM, we suggest to use the new option. Now, I want to add also more rest rough operation. I want to do save and copy tool. I want to add now new tool, and this is the new tool. The same. Now I want to use. We can change here to center, the same tolerance, but my step down is 1 millimeter here, and minimum offset 3. Also, when we work with this step down and minimum offset, with the new option, we can calculate the all. You can see now in the new dialog, we do a lot of calculate. Before, we calculate the 2D stock, and after this, immediately we start to calculate the passes. Before, we want to calculate for the first operation, second operation. It's really take a lot of time, but today you can see how fast we can do this. And this is the reason today, if we talk about the HSR, HSM, we can see here powerful. We can see easy to use. We can see faster. That means they always work fast and fast. And this is the reason, if we talk about 3-axis solution, HSR and HSM today really the best. Now we can see we calculate the passes. Of course, I work here with small tool. My step down is 1 millimeter. My step over is 3 millimeter. You have here a lot of material to cut, and this is the reason it's take time, but generally is fast with the new option. If we compare with the old version, no chance to compare, because today really faster. After this operation, I want to add semi-finish operation. I want to add linear operation. I want to use holder. I want to show the simulation in host CAD. It's really very nice, and you don't need to do a solid verify to see the tool path to see if the all is okay. Today also, when we also do demonstration, it's really work fast and nice. We start to calculate the link now, and we can see generally work nice and fast. Now, after we finish the calculation, I want to run solid verify simulation, but not the standard solid verify. I want to run the solid verify for 3D. Why we need this? Because this simulation is work fast if we use the thing. If all the previous operation is 3-axis operation like HSR, HSM, HSS, we can see the simulation work really fast. And after we finish this operation, I want to show the solid verify for 3D with this big part, and you can see really fast we can do the simulation, check if we don't have any problems in the model, in the stock, if everything is okay. Now we can see we finish the link. Nice. Now, if I go to simulation, we have here the solid verify, but we have also solid verify for 3D. This simulation, it's only for this part. Also, this simulation for all the HSR, HSS, and HSM operation. If we start the solid verify, now first we calculate the first setting, because the simulation needs this, but after this you can see how the simulation works fast. Okay, we're ready here, and now we can start. You can see very big part, big tool, everything is work fast, and also the quality in this simulation also is really very good. You can see the all clear. Any problem, any damage we have in the part, we can see in the simulation, because we see the all really with. Now we start to do the rest rough also. If we look for the rest rough, we can see how the simulation really work fast here. And for big parts, for HSR, HSM, and HSS operation, always I suggest to use this simulation, because this simulation, we add this simulation special for this part. I think it's enough. We see how the simulation really work fast. We can stop. And now for this part, I want to add HSM operation to show also the linear also work fast in big parts. For this, I want to add HSM operation. I want to select the linear tool. For this part, I want to add new tool, and also here we can add holder. I want to use this holder. About boundary, I want to add new boundary. We have new boundary now. Okay, center is okay. 0, 0. And now I want to change the step over to 2 millimeter. My angle is 45 degrees, because if we want to add linear, of course, it's better to work with angle. The all is okay. And for semi-finish, if I work with 0.33, I think the tolerance can be also 0.5 because my wall and floor is 0.3, step over 2 millimeter, the angle 45 degrees. That's all. Now we generate STL because I work with different tool tolerance, but in finish, really HSM work fast, and you can see now very big part. You can see the calculation for the passes more 60-70%. Now we start to calculate the linear. We finish immediately, and we can run the host CAD simulation. Now I want to show now the host CAD simulation. You know, in the host CAD simulation you can show today the holder, the tool, everything. We can start, and really you can see very nice tool holder. We can work more faster here. And if we look for this part, you can see really we have very nice tool path here. Also with this complex part, the all is really work nice. This is what we have here. You can see how the simulation also with big parts work faster. You can see the holder. You can see where is the tool is working. We can see the nice tool path here, and also how we can do this. Really easy. Now we finish, and in this part we talk about several things. First, SolidCAM with HSR and HSM today is faster. The new option when we calculate the updated stock, we see also, if we compare with the regular, also work fast, and they're easy to use. We can see really very complex part with 3, 4, 5 operation with HSR and HSM we can finish, and we do the best here. Now I want to show the next example, and I want to show really the power for the new HM operation. Yes, this is the example 2. In example 2, we do part, and in this part we can see we have 3 area. For me, if I want to talk for this area, this is core. For me, core, the part open from all the side. Here is cavity. What mean cavity? Cavity is closed from all the side, and here we can see we have here core and cavity, and this is the reason we use here HM spiral. If we talk about this part, first if I open the operation, you can see here we use HM. For me, this is the model. I use 20 millimeter tool, and this is my boundary. I want to cut the core. If we go to the passes, here the power for this operation. In the step over type, we have 3 options. The first is core, cavity, and HM spiral. If we run simulation and show how the tool start to cut this area, we can see the tool start from outside to inside, work like core. Always the tool want to start from outside to inside. We can see here the all really work nice. And now if we run solid verify, you can see this more clear. You can see this more clear, and we can understand what we missed this operation in the HSR before. I think now HSR with the with the HM operation, it's really complete. We can do the all. We have many operations today, and I think the operation today it's really work very nice. You can see how we can cut core with this operation. If we go to the next operation, we talk about now cavity. Cavity, the hole is closed. It's enough to run the simulation. You can see the tool start from inside to outside. We can see he start with the ramping, the helical ramping, and he always start from inside to outside, and we cut the part. The last area we talk about open pocket, and to do this, of course, the best option is HM spiral. If I run the simulation now in to this area, we can see the tool start from outside to inside, and after this, if he cannot start from the outside and only inside, he can do helical ramping and finish the part. You can see after this we do this. If we run solid verify, we can see this clear. If we do zoom here, we can see how the operation is working. You can see always start from outside to inside like open pocket, and I think this is the best way to cut this kind of parts, kind of area, and you see the all is okay, no crash, very smooth tool pass. And if we look for the operation, it's the same, all the HSR operation, the same option. Really the different here, we have core, cavity, and HM spiral. This is the new operation. Of course, I suggest always to use now the new HM roughing. You can really work very fast with this operation. Now, I want to show now the last example, and really to show now the easy to use in HSR, HSM. For this operation, for this, I prepare really very nice. I have very nice example. Okay, the part also is big part. We talk about 576 millimeter, but I want to show really how we can cut this very nice area. Now, we can start the part. And now I want to define coordinate system. We talked before, one click and we have coordinate system. We continue. I want to define now, okay, my SolidCAM settings is automatically, but we can see one click and we have the stock and the same in target. If we have my option to select this automatically, but we can do this also in one click. One click unselect and one click select. You can see how fast we can do this today. Now you can see in few seconds I define the CAM part and we're ready to add operation. Now I go to the settings, change to special for HSR, HSM, and now I can start to work. I want to add HSR operation, of course HM tool, and I want to add new tool, 30 millimeter. External 0.56. My step down is 5 millimeter, and that's all. In one click we define the HM roughing and we start to cut. Really, this is the power for HSR, because we have formula in all the fields, in all the parameters. In one click, we can define the all, and also the all is work fast. And we can see we start from outside to inside, and after this you can see always we start from outside to inside. Very smooth tool pass, very nice tool pass, and we can move the all, and if I stop and in one click I can show all the tool pass. Now I want to continue, but to cut this area it's not important. I can add horizontal and finish this. I want to show how we can cut all this really complex geometry here. First, I want to add HSR because I worked with big tool before. Change to, it means I want to do 7th copy, change to rest, and I want to add this tool 60 millimeter. I want to define area here. Auto constant set, my boundary is ready. .6, my step down is 1 millimeter, minimum is 3, and okay, I can select the boundary, the operation, and do calculate. We can see now we calculate the passes. We use the new option special for HSR, HSM when we calculate the updated stock. We calculate the link. Now we finish the calculation. Now we can run the simulation to see really we do rest rough. I think it's enough. And now I want to continue with HSM operation. I want to add HSM operation. Go to parallel pencil milling. For this I want to add new tool, and my diameter is 10 millimeter. The same boundary. This is the parallel pencil milling, 0.3, the same tolerance. Passes. My horizontal is 0.22, and here I want to change to 10. That's all. We do the calculate, and now I want to cut all the fillets in the part, and after this I'm ready to add semi-finish operation. For the semi-finish operation, if we look for the geometry, of course I want to choose the 3D constant step over. This is the best technology to cut this complex geometry. I want to do this after we finish. Now we can run the simulation, and you can see we cut the fillet, and if I do zoom, really we can see very nice toolpath. You can see the toolpath here, how the option is working. It's really very nice toolpath. I think now after this operation I can add semi-finish operation. Save and copy. Change to 3D constant step over. I want to use the same tool, the same boundary, also here the same boundary, external, external, and now horizontal and vertical also 1 millimeter, but I want to start from outside, from first passes, that's all. And now I can start to calculate the operation, and you can see now really very nice tool pass with the 3D constant step over, because really we cut here special geometry, and we can do this all with 3D constant step over. We finished the calculation. Now I want to run the simulation to see really the nice toolpath here with this part. Now if I do zoom like this, you can start how the toolpath working. We can see we start from outside to inside, and you can see the complex geometry, the smoothing toolpath, also the easy to use to have this toolpath. We can see geometry tool, select the 3D constant step over, start from outside to inside, and today we don't need to wait to run the all. I can close, go outside, and in one click I can see the toolpath. This is really the nice with this option. And if we look for the toolpath, really we have very nice toolpath. We have only one approach and one retract. Very nice linking here. You can see the smoothing linking, and this is what we can do today with HSR and HSM. Now I want to show also very nice option we add, and I want to select these surfaces. I want to change the color to green. Now I have the part with this color, and I want to do finish in these surfaces. How we can do this with HSM? I select HSM, 3D constant step over, tool. I want to add small tool, 8 millimeter, drive. I want to select the option selected faces, new, and offset 0.05, and in the drive we have the option define. Now in SolidCAM we add color option. First I can do pick from model. When I pick the model, you can see I select the color. After this, find the faces. Automatically, I have all these faces, and we continue to calculate the boundary. We finish here, and now we calculate, because this is selected faces, we calculate the boundary with the tool like the tangent option. We do this very fast. Don't forget, we talk about big surfaces here. The same in the constraint, selected faces. I want to select the same boundary. And horizontal 1 millimeter. I want to start from inside, and I want to do calculate. Now we can see really very nice toolpaths also to cut the surfaces. And after this, I want to talk about the tolerance and fit arcs, how we can do really high polish if we need to do these surfaces. Now, if we do zoom, we can start, and you can see the nice toolpath here. We talk about the surfaces, but you can see one approach and one retract. Very nice toolpath, very smoothing toolpath, and we work inside the surfaces. And if we look now for the all, you can see really very nice toolpaths we can get with the 3D constant step over. Now, if I go inside the operation, SolidCAM always improve the user interface, also in tolerance and in fit arcs. Before, it's difficult to explain what mean tolerance in HSM. If we look for the picture here, and also we can look for the slider. Of course, we have here the maximum is 0.1, and I have here 5 station till 0.002. And now, if we look for the picture, really you can understand what mean tolerance inside the HSM. Of course, in SolidCAM settings, we can define all the station for the tolerance I show later. And if you want to do something special for this part, and you don't need to change the default in SolidCAM setting, always you can go to tolerance and change to 5 and use this tolerance. But for new user, for demonstration, this is the best way to show the power, the easy to use in HSR and HSM. And now I want to talk about point reduction. I think also a lot of users sometimes don't understand really what happened here. First, what mean point reduction? You can look for this picture. The same, we have slider here with station, and in SolidCAM settings we define all the steps for the tolerance. But with the new picture now, I think is clear what mean point reduction. But now, how we can work with point reduction, how I can cut these surfaces and do high polish here. First, of course, I want to work with high tolerance, like 0.002. And what we have here, to work right with HSM, with point reduction, we need to know really what happened here. First, fit arcs. Fit arcs, they all know, if we have support in the post-processor, we talk about short G code, more G2 and G3. If we don't have support, you can work without fit arcs. The result is more calculation and long G code. But it's not enough. But if you want to do really the best result, that means I want to do here high polish. Always we suggest, after we tested in a lot of parts, to work without tolerance, and we can see not only 0.02, I'm always changed to 0. Now, if we want to cut this area, we see here I change to 0.02, I work without fit arcs. I work with tolerance, but my tolerance is 0. I check this in the Technology Center in SolidCAM GmbH, and after we do this, really we get the best result. And always, if you don't have any limitation in the memory for the machine, you can, and you, of course, you want to do high polish, work with high tolerance, work without fit arcs, do check on in the tolerance and put 0. After this, really you can see the power for HSM, the high quality with the tool pass, and you can really do high polish if you want to cut this part. Now we finish and I'm ready for question. Thank you very much.
Unmuted.
Okay, Ahmed, thank you very much for this presentation. We have a few questions. First is from Pedro. He's asking if you can show the settings for Solid Verify.
Again?
Can you show the settings for Solid Verify?
The setting for Solid Verify, that means we talk about settings here for updated stock.
Pedro, can you clarify? I will unmute you. You are unmuted now.
Yes, can you hear me?
Yes.
Yes, I hear you. Hi,
Good morning, Ahmed.
Good morning.
I seen the first part that you are running very fast the simulation.
Right.
What the tolerances and the settings that you are using?
Ah, okay.
I cannot run so
sure,
fast.
Sure. You see, we have here updated stock. In the Solid Verify, I'm working with 0.01. This is for Solid Verify, and for Solid Verify for 3D, you know, with the same tolerance, but we save the updated stock after one operation. But here, we use the same tolerance, 0.1.
Okay. And can you go to the Solid Verify?
Yeah, sure. That means to run simulation Solid Verify?
Yes.
Okay, Solid Verify. Okay.
Now if you go to settings.
Yes.
General.
What you want to see? General? Yeah. Also, the same 0.01 and here 15. This is the default, yeah?
Yes, use the defaults. Okay.
Yeah, nothing special here.
Okay.
And don't forget I'm use not new computer like your computer.
Okay, thank you, Pedro. I hope that helped.
Yes.
Okay, now we have another question from Goran. He is asking about optimize Z level and step down tab in HM roughing operation.
Yes.
Can you explain this parameter and one example?
Yeah, sure. Yes, I want to go to here, yeah? And we can talk about this operation, but I want to change the passes here to 20 millimeter. Yeah, for me it's easy to explain, yeah? Look, if we talk up the operation, the geometry dialog, same all the HSR operation. Tool, also, no change here. Constraint boundary, the same for all the HSR operation. Passes, what we have in the passes? Wall, floor, tolerance, step down, It's clear, and we have the different here. You see step down type, we have constant, and we have constant and flat. About step over, you see this is a step over. We add here percent of the diameter like pocket, and we have here in the stop over type 3 option, core cavity and HM spiral. I show this option. I think if we ask me, okay, what's special also in this operation, really this is the step down type. If I change to constant and we do calculate now, I want to show what happened inside the part. Okay, now if I look from the side, look here. We have here, you see this area? Now, I want to change not to 20, 25 millimeter and do calculate. And now, if I do zoom here, you can see what happened. This is first, this is the second operation, and we don't cut this area. To do this, we have the option now, constant and flat. We can do calculate again, and now he cut this, only this area. But he do 25 millimeter, he go back and cut all this area. This is the special for this option. If we look now from the side, you can see 0, 25, 25, but here you can see we cut also this area. And this is the big change, big difference we have in contour. In contour, we don't have this option. He cut all the part, but this operation, he not cut all the part, he cut only these surfaces. Okay, you have answer?
Okay, thank you, Ahmed. I think.
Welcome.
Okay, just a second. He has another question. He is asking. He said these are nice options. He was asking about the optimized Z level parameter.
That's mean we talk about here. That's mean the step down optimize here.
Yes.
Okay. Now, first, I don't have now special part to show this, but we talk about part with a lot of stairs. I want to change to 1 millimeter to 1 here and do calculate. Okay. I do save and copy. Go to the passes. Change to 5 and calculate again. Maybe in this example I can show the difference. Go to the side, and this is the first operation, and now you can see what happened here. That's mean in some area I add more tool pass, like here you can see. This is not millimeter, this is number of passes. You can see before, if we look for the side, here 1, but before, if we run the simulation here, you can see this is 1. And now, if I go to here, simulation, do 1, and now, if we change between this, this is the tool path, and what we have here, you see, is different tool paths. That means I can add tool paths, but not exactly like 1. That means it's something, that means it's help to me to calculate the part fast, but in this part we cannot see really the result immediately. But if you have very big parts, if you want to work with one, yeah, the calculation time, it's take really more time. But if you change to 1, 2, 3, you can see he never go to the end of the surfaces. He worked before, but the calculation, it's really faster. This is the number of the z-axis. Okay?
Okay, so we have, I think, did that answer a question, Guran? I hope so. We have time for one last question. Okay. How can we optimize retractions and rest roughing?
First, if I go to this operation, we have several options. I always suggest to work link by cluster. If we look for the part, of course, you can see the difference if you work with big parts. What we do here, link by cluster, we take the part divided for 1, 2, 3, 5, 6 area. I start with cluster 1, finish, go to 2 to 3. I think we can optimize all the jumps. That means there are a lot of jumps. Sometimes it can help, and I use this. And sometimes it's not help. You want to do a lot of constraint boundary. Okay, I want to work here, after this here, after this here. That means you can really control all this jumping. But if you try link per cluster, I'm sure it's help.
Okay, thank you, Ahmed. And,
You're welcome.
Thank you, everyone, for attending today and for joining us. This webinar will be uploaded to the resellers forum and where the rest of the webinars are, and you can always watch it. And if you have any other questions, you can, of course, write to us, and I hope we can help.
Thank you very much. Bye.
So thank you. Have a good day.